What is indefinite integral of square root of x multiplied by cube root of x divided by x multiplied by fourth root of x by dx? Usually, we have some additional info about function f of x. In our case, f of x belongs to real numbers and is integrable in that domain. From symbol dx, we know that differential of variable x indicates that the variable of integration is x. Let's rewrite integrand, function inside the integral. We may apply formula which says nth root of s equals s raised to 1 divided by n. First, we can do it to first expression in numerator. In that case, s is x and n is 2. Then, we apply it to second expression in numerator, and in that case s is x but n is 3. Finally, we use it in denominator, and then s is x and n is 4. Finally, we've got x raised to a half multiplied by x raised to 1/3 divided by x raised to 1 multiplied by x raised to 1/4. We can express x as x raised to 1 using formula s is equal to s raised to 1, where s is x. Now, knowing that s raised to n multiplied by s raised to m equals s raised to n plus m, we can rewrite numerator as x raised to a half plus 1/3 and denominator as x raised to 1 plus 1/4. Let's add expressions in powers. First, we may find common denominator of 2 and 3, which is 6, and we have to multiply accordingly numerators. So we've got 1 times 3 divided by 2 times 3, and to this we add 1 times 2 divided by 3 times 2. In that way, we have common denominator 6, and in numerator we may add 3 to 2. We've got 5/6 and we may insert it to our main solution as x raised to 5/6. Then we have to add 1 and 1/4. We change 1 into 4/4 and then we have 4 in denominator and we may add numerators 1 plus 4. We have finally got 5/4 and we may insert it to denominator of main solution. We have x raised to 5/4 in denominator. Now we can use formula s raised to n divided by s raised to m equals s raised to n minus m. In our case, s equals x, n is 5/6 and m is 5/4. Thus, in main solution we have x raised to 5/6 minus 5/4. We must subtract expression that we have in power. To that, we need common denominator, and in our case it will be 12. So we must multiply numerator and denominator of 5/6 by 2 and multiply both numerator and denominator of 5/4 by 3. We've got then denominator 12, and in numerator we have 10 minus 15, which is minus 5/12. While we insert it to main solution, we have now indefinite integral of x raised to minus 5/12 by dx. And after all those modifications, we can easily apply formula for solving integral of s raised to n, which is s raised to n plus 1 divided by n plus 1. We also must add constant c to make sure that we have all our solutions taken into account, as our solution make whole class of function, not a single one. And now, in our case, s is equal to x and n is minus 5/12. We've got x raised to minus 5/12 plus 1 divided by minus 5/12 plus 1 and plus constant c. First, let's just add 1 to minus 5/12 and we have minus 5/12 plus 12/12, thus we've got 7/12. We can insert it to power in numerator of our main solution and in denominator as well. We can smooth it a little, taking advantage of formula which says that s divided by a divided by b equals b divided by a multiplied by s. In our case, s is equal to x raised to 7 12, a is 12, b is 7. And we have 12/7 multiplied by x raised to 7 12 plus constant c. We may also express differently our x raised to 7 divided by 12, knowing that s raised to n divided by m equals mth root of s raised to n. In our case, s is x, n is 7, m is 12. As a result, we've got 12/7 multiplied by 12 root of x raised to 7 plus constant c. Finally, indefinite integral of square root of x multiplied by cube root of x divided by x multiplied by fourth root of x by dx is equal to 12/7 multiplied by 12 root of x raised to 7 plus constant c. If you have any questions, just write them down in comments section below. If you want to see more our videos, don't forget to subscribe.